Hi, I'm Eric Bergener, a Research Vice President in the Infrastructure Systems Group at IDC. I cover primary and secondary storage, as well as block, file, and object-based storage. Today, I'd like to talk to you about how digital transformation is increasing the need for more enterprises to implement future-ready infrastructure with more performance, reliability, and capacity than ever that is more efficient, greener, and more sustainable, and more cost-effective than ever. Let's take a look at how all-flash data centers can meet these needs. First, let's take a quick look at the pandemic. So most organizations have already embarked on their digital transformation journey as they move to more digitized, data-centric business models and modernize their IT infrastructure. While the pandemic impacted IT spend during 2020, the world economies are recovering very rapidly and will actually surpass 2019 spend by 2022. So you can see that this is a relatively short period of about 12 to 15 months where the economy will recover back to where it was prior to the pandemic. The pandemic accelerated enterprises' digital transformation spending, and that will continue to increase as an overall percentage of IT spend in general, with 51% of global IT budgets being focused on digital innovation and or transformation by 2024. Now, the post-pandemic digital transformation spend will be growing at a 12.8% compound annual growth rate through 2024. And in 2024, that will represent over 2.4 trillion US dollars in spend on digital transformation projects. This spending is spread across core, edge, and endpoint locations, and much of it will be used to modernize existing IT infrastructure to better accommodate the needs of the many new workloads that will be deployed as part of enterprises' digital transformation. With the increased focus on big data analytics to drive product and service development, improve customer experience, and make internal operational processes more efficient, many enterprises will be adding artificial intelligence, machine learning, and deep learning-driven workloads. And these workloads will be significant in generating the infrastructure modernization requirements that most enterprises have already realized they will need to undertake. And this is what is really driving the need for the all-flash data center to meet these new requirements of the infrastructure. Now, the AI-driven storage infrastructure itself, that market will grow at a 5-year CAGR of 22.1%, and it will surpass $6.5 billion in revenue by 2025. So this will be a major area for spend going forward. Now, digital transformation is driving massive data growth, and enterprises will be creating, capturing, storing, protecting, and analyzing more data than ever before. If you take a look at the daily interactions on a per-person basis that are driven by digital transformation, you can see that they're huge in 2025. So this is really driving a lot of this data growth. This data is being captured and used by enterprises to basically provide better products and better services to their customers. Now, in 2025, the world will create 163 zettabytes of data, which is more than 10 times as much as was created in 2016. Handling data growth at this scale requires a scale-out architecture, much denser IT infrastructure, performance and capacity density. Those are key factors that are driving the need for the all-flash data center in the coming years. Now, data is growing across all locations, core, edge, and endpoint, but core IT infrastructure will be storing the most data by 2024. In fact, in that year, out of a total of 13 exabytes stored, 7.9 exabytes, or almost 60% of it, will reside in the core IT infrastructure, driving a need not only for scalable storage capacity, but for systems that can also deliver performance and availability for this data. And this data is becoming increasingly mission critical for enterprises, hence the need for higher availability. Now, as enterprises build their future-ready infrastructure, the need for a successful digital transformation, IT organizations are facing 5 challenges: reliable, highly available infrastructure, improving cost effectiveness of infrastructure and operations, supporting data innovation that will be needed in the new digital world, driving real-time and agile operations, and deploying intelligent management capabilities that will be required to handle the increased complexity of the hybrid multi-public cloud operations that are basically the definition of future-ready infrastructure. By 2024, over 24% of all data collected will be real-time data. That is, data that needs to be used to drive business decisions within 2 seconds of its creation. And that will require the kind of performance that only all-flash systems and data centers can provide. Now, as workloads evolve over time in terms of their performance, availability, and capacity requirements, IT infrastructure needs to be very agile so that it can non-disruptively evolve over time as needed to meet changing business requirements. Why will all-flash data centers be on the rise going forward? It's already clear that all-flash storage has grown significantly, and it currently drives roughly 80% of the primary storage spend in enterprises today. Flash brings performance, increased capacity densities, decreased energy and floor space consumption requirements, and improved media reliability and ruggedness that older storage device technologies like SCSI and hard disk drives just can't match. These are all capabilities that improve the efficiency of the IT infrastructure and lower costs. Now, new technologies like NVMe, persistent memory, storage class memory, quad level cell, flash media, they all expand the reach of flash-based products, enabling their use with more performance-sensitive workloads, while at the same time making the all-flash data center cost-effective for secondary workloads like backup, archive, and disaster recovery. It's clear that flash is no longer just for latency-sensitive workloads. It's a more efficient medium to handle high throughput requirements, move large data sets faster for migration and recovery purposes, and create infrastructure that draws less power, is more compact, takes up less floor space, and is more reliable. All features that are attractive to most workloads, not just those that are extremely latency sensitive. And flash also enables the use of storage management capabilities. Things like thin provisioning, compression, deduplication, encryption, and others, using these features in line without any noticeable performance hit, allowing their use with latency-sensitive workloads to even further reduce the total cost of ownership of the all-flash data center. So all-flash storage is not just for latency-sensitive workloads. And it's now widely available in scale-out, file, and object-based storage platforms as well. These platforms need what Flash brings to the table to handle the demanding requirements of the new workload types. In particular, artificial intelligence is a key one that requires these kind of capabilities. And while there may still be certain colder workloads that are more cost-effectively handled with hard disk drives, we are moving to a future where about 90% of a digitally transformed enterprise's workloads will be more cost-effectively handled by the all-flash data center strategy. Now, all-flash arrays already drive 80% of primary storage spend on a worldwide basis, and the price per gigabyte of flash media will continue to drop with the use of newer technologies like quad-level cell and penta-level cell flash media. This continued decrease in the price of all-flash media, something that is declining at roughly 26% per year, will only make the all-flash data center that much more cost-effective, and hence that much more attractive. Now, a new interface called NVMe was developed specifically for use with solid-state media, and relative to older SCSI, NVMe and PCIe offer lower latencies, more bandwidth, and significantly greater parallelism, a feature that's particularly important with the broad use of multi-core CPUs in today's servers. NVMe is clearly a more efficient protocol than SCSI, and it really opens up the full capabilities of the flash medium in terms of performance, capacity utilization, and endurance, all factors which were limited by use of the SCSI protocol. Now, NVMe-based all-flash arrays are the single highest growth external storage market today, and it's because enterprises understand and want the performance and efficiency advantages that NVMe unlocks in storage systems. The NVMe over Fabrics storage network protocol was introduced several years ago, and it enables all the performance of NVMe-based all-flash arrays to be delivered all the way to the application servers. More and more of these high-performance storage systems will be connected to servers using it, i.e. NVMe over Fabrics, over time. And it provides different transport options like Fibre Channel, Ethernet, and InfiniBand that give enterprise customers significant choice in how they deploy it. Now, an all-flash data center built using NVMe and PCIe technologies will clearly be more cost-effective and efficient than data centers built around older SCSI technologies. Well, one of the interesting technologies that NVMe enables is the rise of memory-driven infrastructure. So emerging persistent memory technologies provide another performance and cost tier that's between DRAM and NAND flash SSDs, giving customers additional flexibility in configuring the needed performance into their all-flash data centers very cost-effectively. Now, this memory-driven infrastructure, based on media types like Intel's 3D XPoint, come in both byte and block addressable storage devices. Persistent memory is a byte addressable device, while storage class memory is a block addressable device. These devices deliver much better performance than NAND flash-based SSDs at a slightly higher price. And persistent memory is in fact faster than storage class memory and slightly more expensive. The key features that differentiate these new memory-driven technologies are from DRAM are, number one, their persistence, their persistent media, and also the higher capacities than they provide than DRAM. So online transaction processing databases and other real-time workloads, particularly in the artificial intelligence space, can benefit significantly from memory-driven infrastructure. And this infrastructure will be attached using NVMe and PCIe and or NVMe over Fabrics storage networks. Now, one of the interesting aspects of memory-driven infrastructure is that for very low latency workloads, it can enable a much smaller back-end persistent storage infrastructure. That's because you need fewer devices to meet your IOPS, throughput, and other performance-related requirements. And that's a factor that can help drive costs even lower in the all-flash data center. Now, already many data centers have a hybrid cloud infrastructure, one that spans both on and off-premises deployment locations like public cloud. A unified management interface that provides visibility and manageability from a single pane of glass for IT infrastructure deployed across all of these locations makes this much easier to manage. Now, many vendors are providing this type of cross-domain management capabilities, and they're using artificial intelligence and machine learning-driven monitoring and management platforms to help manage those environments and address some of the complexity that they have. This is a practice known as AI operations or AI ops, and it's clearly the wave of the future in the modern data center. Now, cross-domain management needs to provide the agility to locate workloads in the best deployment location and enable the simple and efficient migration of those workloads as they evolve and the optimum deployment location changes over time. In fact, 84% of enterprises have repatriated at least one workload from a public cloud deployment location back into an on-premise location. This isn't a wholesale migration, but it does mean that things can change over time and the optimum deployment location might be on-prem as opposed to public cloud, depending upon what the application requirements are. Now, cross-domain management also provides some interesting capabilities around workload consolidation. And workload consolidation is interesting because it's a strategy that many enterprises are using as they modernize their infrastructure and move to more performance and capacity-dense systems that can handle denser workload consolidation. What's interesting about workload consolidation is it can reduce the number of storage silos, and it has both economic and administrative benefits as long as those systems being used as the consolidation platform can continue to meet performance, availability, and other types of service level agreements. Those systems will also need excellent multi-tenant management capabilities to address security and other concerns in multi-tenant environments. Now, one of the things that's interesting here is an ability to apply data services with a high level of granularity at the application level. Features like data reduction, data protection, snapshots, encryption, quality of service, and/or replication. These are the kind of features that enterprises need the ability to apply individually to different workloads that might be running on the same system to really achieve the optimum efficiency out of storage workload consolidation. Now, leveraging AI operations gives IT organizations the ability to effectively manage hybrid cloud environments, and it will be an integral part of how the all-flash data center is managed. It will ultimately provide comprehensive self-management capabilities according to policies established by administrators, ensuring that systems will continue to meet performance, availability, and other service level agreements as IT infrastructure scales to handle business and data growth over time. Now, one of the driving factors behind infrastructure modernization efforts being undertaken as part of digital transformation is to build an agile infrastructure that can handle hybrid cloud while at the same time making it more efficient. Flash is just a more efficient medium out of which to build storage infrastructure. It offers lower latencies, higher throughput and bandwidth, higher storage device densities, drives better CPU utilization as a result of lower latencies, which result in needing fewer application servers, and also reducing the spend on software that runs on those servers, the software licensing costs. Flash is more reliable than traditional approaches. And because of its lower latencies, it can much more efficiently accommodate I/O spikes that can be associated with certain workloads, like, for example, virtual desktop infrastructure, which not only drives more efficient storage infrastructure that can be built than can be built with hard disk drives, but it also means that performance tuning tasks with all-flash storage generally go to zero. So in closing, I'd like to provide some guidance in 3 areas for enterprises that are building their future-ready infrastructure today. For those aware of all the advantages the all-flash data center provides, they're a very smart choice, particularly for those enterprises going through digital transformation and modernizing their IT infrastructure. For all the decision metrics IT managers use when purchasing storage, performance, availability, agility, granularity and ease of management, security, easily scalable capacity, reliability, and efficiency, they deliver much better than legacy infrastructure and offer the opportunity to leverage AI ops for high administrative productivity. To maximize the capabilities in all of these areas, enterprises will want to consider NVMe-based all arrays that can support NVMe over fabrics, host connections, when the level of performance is needed. Now, even as they move to an all-flash data center, enterprises should look closely at implementing a storage workload consolidation strategy. Having fewer storage platforms and storage vendors to manage simplifies environments and lowers costs, as long as those storage consolidation platforms offer the right storage and multi-tenant management features. Today's NVMe-based all-flash arrays absolutely offer those capabilities, and this is just one more way to lower costs beyond the natural efficiencies of the all-flash data center. Now, when it comes to data availability and reliability, the all-flash data center exceeds the capabilities of legacy IT infrastructure. Today's newer servers, storage, data protection, and networking infrastructure are able to deliver higher availability than ever before, and solid-state media technology makes them more reliable than ever before. As enterprises move through digital transformation and come to depend more on big data analytics to help drive day-to-day business decisions, they are demanding higher availability than ever from their IT infrastructure. When systems go down, more of the business is impacted than in the older, more analog business model. The all-flash data center meets these requirements, not only in availability and reliability, but also across all the metrics enterprises will be using to put the right data center infrastructure in place. For more and more enterprises, that right answer will be the all-flash data center. And as flash media costs drop, the economic advantages of the all-flash data center will become increasingly compelling. And I'd like to point out one last time that all-flash storage has already taken the industry by storm. It dominates primary storage with newer flash media technologies and architectures, and with additional innovation is beginning to cost-effectively handle many secondary storage workloads as well. The sheer amount of data enterprises will need to handle to compete successfully in the new digital era requires the capabilities an all-flash data center brings to the table: performance, high availability and reliability, storage density, scalable capacity, energy efficiency, and sustainability, all of which contribute to an enterprise's ability to leverage their data to drive faster innovation, make better business decisions, and lower the total cost of IT infrastructure ownership. Thank you for your time and attention today.